Welcome to Excel and Business Math video number 16. Hey, in this video, we got to talk about adding and subtracting fractions, the least common denominator, and even the LCM function in Excel. Now, here are our topics, and guess what? Adding and subtracting, unlike fractions, is going to take a bunch of steps. So we're going to see how to do it by hand and in Excel. Now, the method I use, and I just made this name up right here, LCD times 1 method. The method that I use is probably different than the method you've used to add and subtract unlike fractions. Now, I like this method here because it actually reveals the meaning of why the method is OK to use. Now, there's a link down here. This is a great website. There is not just one way to add or subtract unlike fractions. So this link right here shows you 4 awesome methods. And one of the methods is almost like mine, except for they forget to multiply by 1, which shows us the meaning of why all of the steps that we're going to do here actually make sense. All right, now we're going to start off by looking at PDFs. Then we're going to go do all of this by hand on a piece of paper with a pen. All right, here's our website, and you can click the link below the video. We want the PDF notes for videos 11 to 17. So I'm going to click on this, and we have to go to page 18. And here it is, page 18. Add or subtract like fractions. Remember, like fractions means they like each other. No, no, no. A like fraction means the denominators are equal. Now, adding with like fractions is easy. You simply add the numerators, keep the denominator. Here's our first example. And think of pizza. You had 2/5 of the pizza, and your friend had 1/5 of the pizza. So just using common sense, not even thinking about these rules, you know that you two together had 3 of the 5 pieces of pizza. Now, the steps here, we look at the 2 fractions. There's an operator. It's got to be either addition or subtraction. The denominators are the same, so we simply bring that denominator over, take the operator, place it in the top, and the 2 numerators. Then we perform the operation to get 3/5. It's the same for subtracting. 2/5 of the pizza was left. You took 1/5. Notice the operator. We bring that over, boop, list the numerators, and take the denominator. 2 minus 1 is 1, so we're left with 1/5. Now, example 3 here, we actually did this example 2 videos ago. This is one of the methods we use to go from an improper fraction into a mixed number. Notice 8/3. We rewrote it as 3 plus 3 plus 2 over 3. Now, when we broke it apart using the plus symbol and putting each one of the numbers from the numerator as a separate numerator in 3 different fractions, and then repeated this 3, 1, 2, 3 times, we actually were using the adding, subtracting like fractions rule backwards. Because in this video, we're doing it in this direction. We're taking 3 separate fractions and noticing that the denominator is the same, writing it one time, taking 3 numerators, the operators, putting them in the top. So 2 videos ago, we did adding, subtracting like fractions backwards. This video, we're doing it forwards. Either direction, it's still valid. Now we want to go to the next slide, and we want to talk about how to add or subtract unlike fractions, right? These are the ones that don't like each other. No, no, no. It means the denominators are not equal. So if you look at 5/8 plus 3/12, how in the world are you going to do that? The denominator is not the same. Well, the whole trick for adding with unlike fractions is to somehow convert this fraction and this fraction into 2 new fractions that are equivalent to the original fractions but have the same denominator in each fraction. Now we're going to go through all of the steps here. I wrote them out very carefully in the PDF notes. After we look at these, we'll go over and we'll do the same problem all by hand in a more condensed version. But as we look through the pages 19, 20, and 21, they describe not only with an example, but with words and steps, exactly the steps that we're going to use to add unlike fractions. All right, so step one, you have to break apart each denominator into prime factors. So there it is, 8 and 12. We list them, 8 and 12. Those are the denominators. And then we break apart 8 and 12 and list all the prime factors. Now, we might have to do our little trick to finding all of the prime factors, whether on paper or in Excel, as we've learned earlier in the class. But there it is, step one. Now, step two, look at this. We're going to count the number of times each prime factor appears in each list of prime factors. Here's one list of prime factors. Here's another list of prime factors. I am counting on my fingers. There's a 2, that's the first one. There's a 2, that's the second one. There's a 2, that's the third one. Then we start over for the next list of prime factors. There's 1, 2, 2 2s. Oh, okay, so 2 2s here, 3 2s up here, and there's a single 3. Step 3, take the largest count for each unique prime number. Now, unique means, well, we have amongst all of these a 2 and a 3. So I have to look through all of them for each list and find the biggest count for 2. Well, it's either 3 or 2. Since 3 is bigger than 2, I'm taking 3 2s. And I list them down here. 2 listed 3 times. Then the next unique prime is 3. It's only listed once, so I list it down here. 3 listed 1 time. Now, what are we going to do with these lists? That's the next step. Now, terminology. The next step involves determining the LCD, either least common denominator or lowest common denominator. Or the more general description is least common multiple. Now, you could say least common multiple, especially since the function in Excel is LCM. But really, this is a more specific situation. We are finding the least common multiple in the denominator. So that's why we're going to use one of these, LCD. All right, you ready? Oh, wait a second. Last step, we had to list 2 3 times and 3 1 time. Now let's see what we do with those. Step 4, write each prime as many times as you counted in the last step and multiply to get the LCD, least common denominator. Oh, there's the 3 2s separated by the multiplication symbol. And there's the 3 with a multiplication symbol. 2 listed 3 times, 3 listed 1 times with multiplication. Now when we multiply them, there's the magic denominator we need for each one of those fractions, 24. If 24 were in the denominator of both, then we could add. But how are we going to get those fractions? We cannot just change those denominators to 24 because then it would change the actual fraction. And we need the value of the fraction to stay exactly the same. So step 5, determine what factors each denominator needs to become the LCD. All right, so we actually relist denominator, prime factors, and we ask the question, hey, 8, what do you need to get to 24? Well, we need a 3, because 3 times 8 is 24. Another way to think about it is we just look at this list right here for 8. 2 2 2, and then I look up here. What is this list missing from up here? It's missing a 3, so I bring it down here. Now we have to do it for the next one. There's 12. There's the prime factors. What does it need? What does 12 need to get up to 24? Well, a 2. 2 times 12 is 24. Or you simply look at this list, compare it up here. What's missing? 2, so I bring it down here. Now, denominator 8 needs a 3. Denominator 12 needs a 2. Now look at this. Step 6. This is the multiply by 1 step. Multiply each fraction by the number 1 with the goal of ending up with like denominators. Hey, look at this. Let me ask you a question. 5/8 is 5/8 times 1 equal to 5/8? Absolutely. How about 3/12? Is 3/12 times 1 exactly equal to 3/12? You betcha. Any number times 1 is that number. The trick is to convert the 1 to a specific type of 1. Remember, what does 8 need to get to 24? Well, it needs a 3. So you choose that 3 and rewrite it as the number 1 right there. Look at that. 5/8 times 3 over 3. Is that the same as 5/8 times 1? And is that the same as 5/8? 1, 2, 3. Those are all equal. So look at that. We have not changed the value of the 5/8. We just multiplied it by a really smart number 1. Now we have to do the same thing for 3/12. I look up here. 2 over 2, that is 1. So 3/12 times 2 2s is the same as 3/12 times 1, which is also the same as 3/12. Now look at that. We can multiply numerators, denominators, numerators, denominators. Notice multiply, multiply, plus, of course. Order of operations says do the multiplying first. So let's do it. 5 times 3 over 8 times 3 plus 3 times 2 over 12 times 2. Now that equals 5 times 3 is 15. 8 times 3, ding, ding, ding. That's our 24. 3 times 2, 6. 12 times 2, 24. That is absolutely beautiful. We have transformed our two fractions, and now they have values that are equal, because all we did was multiply by 1, and the denominators are 24. Now we can simply take the operator, the two numerators, list them over the new denominator. We get 21/24. And be sure to reduce to get the final fraction. Look at that. We've actually, in the last few videos, used 7/8 a bunch of times. But now we want to go over to PowerPoint, and I want to by hand do this entire example in a more condensed way that'll make it easy for all of us. All right, let's go over to PowerPoint.
All right, so we want to use our steps to add unlike fractions. And we're going to do our same example. 5 divided by 8 plus 3 divided by 12. Now, step 1. We are going to list the denominators. And I'm going to put an 8 there and a 12. I'm going to put a 12 here. Put a line. Put another line here. And we have to list our prime factors. So we have to look for each. And I'm going to draw a line. Now, if you want off to the side, you can do your trick where we're saying, starting with 2, how many 2s are in 8? 4. How many 2s are in 4? 2. And then there's one prime factor left in there. We're left with 1. So the prime factors are 2, 2, 2. So 2 times 2 times 2. Now we do the same thing for 12. Let's see, there's a 2 in there. 6 times a 2 goes in there. There's a 2 in 6. There's 3 of them. That's a prime number, so we list our 3 and a 1. Those are the prime factors for 12. So 2 times 2 times 3. Now, step 2 is counting the number of times each prime factor occurs for each list. So I'm going to put a little 1 up above. Hey, there's a 2 one time. Oh, there's a second time. Oh, there's a third time. Now we're going to go to the next list, and we're counting. Well, there's a 2. That's the first one. There's a 2. There's the second one. That's it for 2s. Now we go on to the next one. There's only 1, 3, so I'm going to put a 1. So we counted how many times each prime factor occurred in each list. Now 3, we have to find the largest count for each unique prime factor. And you can look at the full written description for each step back in our PDFs. Well, how many unique prime factors are there in this whole thing here? Well, there's just a 2 and a 3. So I have to look through. Let's see. For 2, there's listed 3 times. For this 2, it's listed 2 times. So the largest is 3. So in step 4, that's figuring out what the LCD is. We've determined we need 3 2's, so I'm going to list the 2's and put multiplication between them. Then for the unique prime 3, well, there's only one of them, so we put it down here. Once we've gone through the lists of prime factors and figured out the largest count for each unique prime factor, we simply multiply them. And here we get 24, and that's our lowest common denominator, or least common denominator, or least common multiple. Now, step 5, we got to figure out what each denominator needs. So I'm going to put needs up there. Well, we're looking through all of the prime factors that determine the LCD. Now we're going to look up at the denominator 8. What does it need to get up to 24? Well, there's 3 2's here, 3 2's here. It's missing a 3. So I'm going to put a 3 here. That's what it's going to need to get up to 24. Now, what does the denominator 12 need? Well, we got 2, 2, 3. It's missing a 2, so I put a 2 here. Now, the final step, this is the ones step. I'm simply going to rewrite the original down here. And I know any number times 1 is still itself, so I'm going to multiply it by 1. Plus 3 over 12 times 1. Now, I'm doing this little step right here just to emphasize the ones aspect of this method. Because if you can clearly see right off the bat that this next step, you can skip this step right here. I'm going to rewrite it 5/8 times some particular 1 plus 3/12 times some particular 1. Well, now we ask, what does 8 need? It needs a 3. So I'm going to write 3 over 3, which is 1. Now I'm going to ask the question of 12. What does it need? It needs a 2. So I write 2 over 2. That is times 1. So now we can do multiplying and then adding. Rewrite it down here. 5 times 3 over 8 times 3 plus 3 times 2 over 12 times 2. And here comes the magic, right? 5 times 3, that is 15. 8 times 3, that's 24. Plus, I'm rewriting this. 3 times 2, that is 6. 12 times 2, that's 24. And there it is, the magic of LCD. We have 2 fractions that like each other now. The denominators are the same. So now we can take the operator and the 2 numerators. 15 plus 6 divided by 24. We get 21 over 24. And if we break that apart, 21 is made up of prime factors 3 times 7. And 24, that's made up, well, you might have to come off to the side. If you can't see all the way through, how many 2's are in 24? 12. 2's in 12, 6. 2's in 6, 3. 3's in 3, 1. So it's 2 times 2 times 2 times 3. And we're left with, oh, cancel the 3 in the top and bottom. And I'm left with 7 on the top, and 2 times 2 times 2 is 8. There is the answer. So if we write it out, 5/8 plus 3/12 equals 7/8, that is a true statement.
All right, that's how to add unlike fractions. Let's go see how to subtract unlike fractions. Next slide. Now I'm going to put on a little music here and do this one to music.
was a little fun with music. Let's see how to now add unlike mixed numbers. Well, not add, this should say subtract. But the method we use for adding and subtracting are the same. The first thing we have to do is we have to deal with the fact that we have fractions and they do not have the same denominator. So we're going to do step 1, list the denominators, 4 and 5, and we'll have to list the prime factors. For 4, it's going to be 2 times 2. Oh, look at that. 5 is just, that is a prime. Now we're going to have to do step 2, count. For each list of prime factors, how many of each? Well, this one's easy, 1, 2, so there's 2 2's, and there's 1 5. Now, step 3, we have to list largest count of unique prime factors. Well, this one's easy. For step 4, LCD, that's going to equal, well, this one and this one. 2 times 2 times 5, and let's see, that must be 20. Now we do step 5. What does each denominator need to become the LCD? 2 times 2, well, 4 is missing 5. I'm going to draw a little line here to make it a little bit easier. And 5, it's missing, well, 2 times 2 is 4, so I'm going to list it as 4. Now step 6, 3 over 4 times 1, and I'm just going to skip the 1's. Since this is 4, I look up here, I need a 1, and the form of the 1 we're going to use is 5 divided by 5. And I'm going to say minus because just doing the fractions up here, we still have to take 3/4 and subtract 2/5. Minus 2 over 5. And we're going to multiply it by a particular type of 1. It looks like 5 needs a 4. 4 over 4, well, that's equal to 1. So now we can simply do our multiplying first. 3 times 5 over, and I'm going to take 4 times 5 as 20, minus 2 times 4, and I'm going to list that as 20 because I already know what the LCD should be. Down here I'm going to say equals 3 times 5 is 15 over 20, minus 2 times 4 is 8 over 20. So I'm going to be left with 15 minus 8 over 20 equals 7 over 20. So now I can use this all the way back up here. So I'm going to subtract. And when I subtract these two, I'm going to get 7 over 20. Then I'm going to take 3 and subtract 1 and get 2. 8 and subtract 2 and get 6. So my answer is 62 and 7/20. So if you break it down, even something complicated like this is quite easy and even a bit fun. All right, now we need to go over to Excel and see a few tricks in Excel.
All right, we're on the sheet add and subtract fractions over here in our Excel workbook. Now, really, when it comes to adding and subtracting unlike fractions, even I, who uses Excel all the time, I use a piece of paper. But let's look at something interesting at least. What if we want to add 1/16 plus 2/3? Well, I'm going to list them as labels first. Remember, lead apostrophe 1 divided by 16. That's not really 1 divided by 16. That's lead apostrophe. So 1/16 as characters. Enter. Lead apostrophe 2/3. Enter. Now I'm going to make a formula because I want the actual decimal first, and then we'll format it. Equals 1 divided by 16. Enter. Equals 2 divided by 3. Enter. Now I'm going to click in the cell, Control 1, Custom, and I'm going to use question mark slash question to show 1/16. Enter. And now the second one, Control 1. I want a single digit in top and bottom, so question mark slash question mark. Enter. Now, if I come down here in Excel, I can just use the sum function if I'm adding Alt equals and Enter. And look at that. It gives me 35/48. Now, if I can do all this in my head and verify, then I'm done. But if not, we can actually over in Excel use the LCM function, least common multiplier. It'll figure out the LCD automatically. Now I'm going to list the numerator 1 and the numerator for the second one 2, and then the denominator 16, enter, 3, enter. Now let's come up here. We have our denominators. And by the way, we have 2 here. We could have 3, 4, 5, or however many. And the equals LCM returns the least common multiple, which will return our LCD. Now I can simply highlight these 2 or however many there are, Control Enter. So I know that the least common denominator is 48. Once I know this, I could take a different approach. I could click right here. If that's the denominator, I'm going to ask the question, what do I need to multiply by 16 to get 48? Well, after a little figuring, I say, well, OK, it's 3. And I'll check it over here. Equals, and I'll get, with my arrow key, the 3 times the 16 and enter. OK, so 3 is correct. Now, what do I need to multiply by 3 to get 48? Well, it looks like I'm going to have to do 16 threes equals 16 times 3. And look at that. It's the same exact 2 factors, but reversed. All right, so that's going to be our final result denominator. So that part is looking good. Down here, I'm simply going to say equals, and I'm going to click on that denominator up there. But the numerator, well, if we were doing this on a piece of paper, that's what we need, right? So we multiplied denominator times 3. Well, if I'm going to multiply the bottom part of the fraction, I also have to multiply the top part, the numerator. Same for this 2. That's the numerator. I'm going to have to multiply it by 16. So you ready? Equals. Hey, that's what I need to get up to the least common denominator times whatever is in the numerator. Control Enter and copy it down. Now remember, if we were doing it on a piece of paper, this would be in the top and the top, but there's a plus in between. So I'm going to come down here, and for the numerator, Alt equals. It didn't get right, so I'm going to come over here and highlight those 2 and enter. And there it is. I've verified that 35/48 is correct. Now I also want to verify if that's reduced. I can kind of do this in my head. 35 is 7 times 5, so those are both primes. 48, that's got nothing but 2s because we had a 16 times 3. So none of the factors in 16 or 3 are 5 or 7. So that is reduced. Now, example number 2. Anytime, just like we did up here, we can just add or subtract. But we definitely have to make sure the formatting shows the correct answer. Now, for something like a like fraction, I simply Alt equals and enter. That formula will suck the formatting from above, and we can verify this one in our head, 3/5. Now, this is the one we did to music just a while ago. Equals 5/8 minus 5/24. Control Enter. And as we know, that is not the correct final result. The number formatting is displaying it as a different number than it actually is. Remember, our final answer was 5/12. So Control 1, and I want to come down to Custom and highlight question mark slash question question, and there we can see our sample. Click OK. All right, so that's a little bit about adding and subtracting like and unlike fractions in Excel, but the main part was over on paper. There are 4 homework problems, and actually I did almost all of the homework on paper, so those answers are over on the red sheet. What do we do in this video? Well, we definitely, back here in PowerPoint, we learned how to add unlike fractions with our 5 steps. We talked about subtracting unlike fractions. We even talked about subtracting unlike mixed numbers. Also, very importantly, over in our PDF notes, pages 19, 20, and 21 list all of the steps, including an example of how to add or subtract unlike fraction. Hey, if you like this video, be sure to click that thumbs up, leave a comment, and sub, because there's always lots more videos to come from excelisfun, including next video number 17. We'll do fraction word problems. All right, we'll see you next video.